Every major tech company in America is racing to build the perfect humanoid robot. Figure AI has raised over $1 billion in funding at a $39 billion valuation and is building a factory designed to eventually produce robots as fast as 1 per hour. Boston Dynamics rebuilt Atlas from the ground up with joints that spin in full circles. Tesla is preparing factory space for Optimus and talking about eventual mass production at a scale nobody else has attempted. The few humanoids with public pricing targets or estimates often sit somewhere between tens of thousands and far beyond that. They're loaded with advanced AI, covered in high-end materials, and designed to be as human-like as possible. And while all of that is happening, a small startup in New York founded by a group of MIT engineers asked one question that nobody else seemed to be asking. Does a humanoid robot actually need legs? Their answer was no. Their goal is to push the cost of a humanoid robot toward around $10,000. And it might be the one that actually changes the workforce. Not because it's the most impressive, because it's the most affordable. The company is called Reflex Robotics, and the first thing you'll notice about their robot is what's missing. There are no legs, no articulated knees, no ankle joints, no complex bipedal balancing system. Instead, the lower half of the robot sits on a wheeled base, a platform that rolls. It looks less like a humanoid and more like a person sitting in a very advanced wheelchair. And that's exactly the point. To understand why this matters, you need to understand the single biggest problem in humanoid robotics right now. It's not the AI, it's not the sensors, it's not the arms or the grippers. It's the legs. Walking on 2 legs is one of the most mechanically complex things a robot can do. It requires constant real-time balance adjustments, dozens of motors firing in precise coordination, and an enormous amount of energy just to stay upright. Every step a bipedal robot takes is a controlled fall, and building a system that manages those controlled falls reliably, safely, in unpredictable real-world environments is staggeringly expensive. That's why most humanoid robots cost what they cost. The legs can represent a huge share of the total hardware expense. And on top of the cost, legs introduce fragility. A bipedal robot that trips, stumbles, or falls is a liability. It can damage itself, damage its surroundings, or injure a person nearby. Every humanoid company in America is spending millions trying to make their robots walk reliably. Reflex looked at that problem and decided to just skip it. By putting their robot on a wheeled base, they eliminated the most expensive, most complex, and most failure-prone component in the entire system. The result is a robot that costs a fraction of its competitors. According to the company, the target retail price is around $10,000. To put that in perspective, Figure 3 hasn't announced consumer pricing, but its company is valued at $39 billion. Boston Dynamics' Atlas was never sold commercially, but each unit reportedly cost hundreds of thousands to produce. Tesla's Optimus is targeting $20,000 to $30,000, and even that is considered aggressive. Reflex is aiming for half of Tesla's price. That's not a small difference. That's a different category entirely. But a cheap robot that can't do anything useful is just a cheap piece of metal. So what can Reflex actually do? The upper body is where the engineering lives. The robot has 2 arms that the company describes as having superhuman reach, payload, precision, and speed. Reflex hasn't published every performance specification publicly, but the design target is clear. These arms are built for warehouse work, where boxes, bins, and containers routinely exceed what a single person can safely lift. The arms are designed for repetitive physical labor, picking up objects, moving them from one location to another, stacking, sorting, loading. The tasks that make up the vast majority of work inside a logistics facility. The hands are built for grip strength and durability rather than fine manipulation. Reflex isn't trying to thread a needle or crack an egg. They're trying to move a 40-pound box from shelf A to conveyor B 1,000 times a day without stopping. That's a very different engineering target, and it's a deliberate choice. Other companies are chasing dexterity. Reflex is chasing endurance and reliability. And that wheeled base that looks like a shortcut? It hides something important. A battery system that the company says gives the robot extended operational time far beyond what most bipedal humanoids can manage. Reflex claims its robot can work through a full shift and beyond without stopping. Many bipedal humanoids still face short runtime limits compared with the full shift expectations of warehouse work. In a facility that runs 24 hours a day, that difference matters. You may need fewer robots to cover the same operating hours. But here's the feature that makes Reflex genuinely different from everything else in the American humanoid space. The robot can be operated remotely. An operator sitting at a desk in one city can control the robot's arms, see through its cameras, and perform physical tasks at a facility hundreds or even thousands of miles away. The company describes it as being similar to playing a video game, Except the game is real, the objects are physical, and the work counts. This is not full autonomy. The robot is not making decisions on its own. It's being piloted by a human who sees what it sees and moves what it moves. And that's the point. Full autonomy is where the hardest unsolved problems in robotics live. Getting a robot to independently navigate an unpredictable environment, make judgment calls, handle exceptions, and recover from errors without human input is a problem that billions of dollars of research still hasn't cracked. Reflex doesn't try to solve it, they route around it. The robot is the body, the human is the brain, and they're connected by an internet signal. That approach has a massive implication for labor economics, because it means a skilled operator in a low-cost region can do physical work in a high-cost facility without being there. A person in Mexico City could operate a robot inside a warehouse in New Jersey. A technician in Vietnam could stack shelves inside a distribution center in Dallas. The physical body is where the work needs to happen. The human controlling it can be anywhere. That decouples the location of the worker from the location of the work for the first time in the history of physical labor. Knowledge work went through this decoupling years ago. Remote software engineers, virtual assistants, offshore customer service. But physical labor was always anchored to a place. You had to be there to move the box. Reflex's model says no, you just have to be connected, and the company isn't building in a vacuum. According to available reporting, Reflex is planning to manufacture its robots in Mexico, which further reduces production costs and positions the company to scale quickly across North America. The robots are already being tested in real warehouse environments in the United States. These are not demo units performing choreographed tasks at a trade show. They're working in operational facilities, doing real tasks alongside real logistics workflows. Now let's talk about the math that makes the title of this video more than clickbait. A single Reflex robot costs around $10,000. A warehouse worker in the United States earns an average of roughly $35,000 to $45,000 a year in wages alone. Add benefits, insurance, workers' compensation, turnover costs, training and management overhead, and the fully loaded cost of one warehouse employee can exceed $50,000 to $60,000 per year. One robot at $10,000, working extended shifts, no benefits, no breaks, no sick days, no turnover. If the robot performs reliably, the payback period could be far shorter than traditional automation, potentially months rather than years. Now scale that. There are over 1 million warehouse and storage workers in the United States alone. Globally, logistics and warehousing employ tens of millions. If a $10,000 robot can do even 40 to 50% of the physical tasks currently done by human workers, picking, placing, moving, stacking, sorting, the economic pressure to deploy these machines becomes enormous. Not because companies are evil, because the math is irresistible. And this is where we need to be honest about what that means. Reflex's robot is not coming for creative jobs. It's not threatening software engineers or doctors or teachers. It's coming for the most physically demanding, lowest paid, most repetitive jobs in the economy. Warehouse work, distribution, fulfillment, packaging, sorting. These are jobs that already have high turnover rates, high injury rates, and chronic staffing shortages. Companies will frame this as solving a labor shortage. And in some cases, that's true. Warehouses genuinely struggle to hire and retain workers for physically grueling shifts. Picture the Reflex robot rolling down aisle 14 of a distribution center at 2 in the morning. The lights are dimmed to save energy because the robot doesn't need full lighting. It picks up a box, places it on a conveyor belt, rolls to the next location, and repeats. Somewhere in another city, an operator watches through the robot's cameras and adjusts the grip when the box is oddly shaped. The warehouse is running. The robot doesn't get tired. The operator doesn't need to be there physically. Amazon alone reports turnover exceeding 100% annually at some facilities, meaning the company replaces its entire warehouse workforce every single year. But the honest reality is that a $10,000 robot doesn't just fill empty positions, it replaces the economic need for those positions to exist at all. When the robot costs less than 3 months of a human worker's salary, the incentive isn't to supplement the workforce, it's to restructure it. The counter-argument is always the same. New technology creates new jobs. It happened with the automobile, it happened with the internet. And historically, that's been true. But the transition between the old jobs disappearing and the new jobs appearing can take years, sometimes decades. And the people who lose the old jobs are rarely the ones who get the new ones. A warehouse picker who loses their job to a $10,000 robot is not likely to become the robotics engineer who maintains it. The skills don't transfer. The geography doesn't transfer. The pay grade doesn't transfer. That's not an argument against the robot. It's an argument for being honest about the consequences. But there's another side to this that doesn't get discussed enough. Remote operation. The model where a human in one country controls a robot in another isn't just a labor arbitrage play. It's potentially a lifeline for workers in developing economies. A person in Manila or Nairobi or Sao Paulo who currently has limited access to high-paying physical work could theoretically operate a robot inside an American warehouse and earn a fraction of an American wage but a multiple of their local wage. The work goes to the facility, the income goes to the operator, the robot is the bridge. Whether that turns out to be exploitative or empowering depends entirely on how it's implemented. History suggests it will be both simultaneously, depending on who's doing the implementing, but the possibility exists, and that possibility didn't exist before a robot cost $10,000. Now let's be clear about what Reflex cannot do. It cannot climb stairs, it cannot navigate uneven terrain. It cannot work in environments that require bipedal mobility, construction sites, outdoor terrain, multi-story buildings without elevators. The wheeled base that makes it cheap also makes it limited. It's a flat floor machine, and most of the world's physical work doesn't happen on flat floors. The remote operation model also depends entirely on connectivity. A stable, low-latency internet connection between the operator and the robot is non-negotiable. Any lag, even a fraction of a second, makes precise physical manipulation difficult or dangerous. In well-connected facilities, that's fine. In remote or underserved locations, it's a real limitation. And the long-term play is uncertain. Reflex is a startup. Startups run on funding. Funding runs on milestones. If the company hits its targets, manufacturing at scale, contracts with major logistics companies, reliable uptime in real warehouse environments, it could become one of the most disruptive companies in robotics. If it misses, it becomes another promising robotics company that burned through its runway. The history of robotics is littered with companies that had great demos and empty factories. The reason Reflex matters isn't that it's the most advanced humanoid robot in America. It's not. Figaro 3 is more sophisticated, Atlas is more athletic, Tesla Optimus has more resources behind it, Phoenix from Sanctuary AI has better hands. Reflex is less capable than all of them, but it costs $10,000, and that changes everything. Because the robot that transforms the economy won't be the one that's the most impressive at a tech conference. It'll be the one that's cheap enough for a mid-sized logistics company in Ohio to buy 50 of them and deploy them next Tuesday. Nobody gasps when they see it. Nobody posts a viral video of it doing a backflip. But 12 months later, the warehouse may need far fewer people on the floor, and nobody made a viral video about that. A group of MIT engineers in New York looked at the most expensive problem in robotics, bipedal locomotion, and decided to just not solve it. They put their robot on wheels. They made it remote controlled, and they priced it lower than a used car. It's not the robot that will leave you speechless. It's the one that will leave the warehouse silent.